All right. When you plug in 2 to this, we get 0 over 0. So that means something should cancel out here, except we got this absolute value going on. So really, f of x equals two separate things here. F of x really equals, remember what we said with absolute value, it either equals itself, so this is just going to equal x minus 2 over x minus 2 if x is greater than 2, because if x is greater than 2, then x minus 2 is positive. And if x minus 2 is positive, then the absolute value of x minus 2 is x minus 2. But if x is less than 2, then x minus 2 is negative, so the absolute value is actually going to change that sign. So you're going to get this if x is less than 2. And we looked at this before, but this equals negative 1, and this equals 1. So f of x really equals this function. F of x, no matter what value you plug into f of x, you're either going to get negative 1 or 1. If you plug a value in less than 2, you get negative 1. If you plug in a value greater than 2, you get positive 1. But at 2, it's not defined because you get 0 over 0. So the question really is, can we do something to extend f of x? Can we add one extra point at 2 and make it continuous? Can we define it at 2 and make it continuous? Well, in this case, no, we can't. And the reason for this is because the limit does not exist. There's a jump discontinuity here. We're going from negative 1 to positive 1 at 2. So I can't just plug in one point and make it continuous. So this is what this function looks like. It goes from negative 1 to positive 1. This is negative 1 down here. Okay? So you can't just plug in one point. There's not a hole there. The only kind of function we can really extend is if there's just a hole. So we cannot do it, and the reason because, so cannot be done because the limit doesn't exist. If the limit doesn't exist, then it can't be continuous no matter what I define the function to be. Because the limit as x goes to 2 of f of x does not exist.